Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Chaotic Desktop by Talking Freddish. And here are the rules. We have Chaos Construction rule set, where we need to place the digits 1 through 6, once each in every row and column. And we additionally need to create six cell regions of orthogonally connected cells, each of which contains the digits 1 through 6. Now, what is an orthogonally connected region? It means you can go from any cell in that region to any other cell in that region by going just through edges while staying within the region. So this is an example of a valid orthogonally connected region, because you can get from any cell in that region to any other cell in that region just by going through edges while staying within the region. This is an example of an invalid orthogonally connected region, because these two cells, while they can get to each other by going through edges while staying within the region, they can't get to any other cells in that region by doing so. They either have to go through a corner, or they have to go through an edge and exit the region, and neither of those are allowed. So that's an example of how chaos construction rules work. We also have files and folders, where each 6-cell region must contain exactly one file and one folder. So this is not valid as a region because we have 2 folders in the region and no files. We have to have one file exactly and one folder. And additionally, digits on file, so that let's use an example that is potentially valid. It's something like this. Additionally, digits on files and folders indicate the total number of cells seen in all 4 orthogonal directions, which just means horizontal or vertical directions, including themselves where region borders obstruct vision. So, for example, this would see 3 cells. It sees itself, this cell, and this cell, but since region borders obstruct vision, it does not see anything past this way, it does not see anything past this way. So in this case, this would be a 3. In this case, this would be a 2, because it sees only this cell here in this direction. It doesn't see any other cells in the horizontal or vertical directions because region borders block vision. So we know the folder sees everything correctly, but one of the files has been corrupted and it indicates the wrong number of cells seen. So this could actually be a wrong number, and you could have, say, like 6 there in one of the files. The folders have to see correctly. So there is that. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, anything that has 2 folders next to each other or 2 files next to each other have to be in different regions. So this must be in a different region, this must be in a different region. This has to go out this way, because it cannot go to orthogonally connect. It has to orthogonally connect out this way. So this sees at least 2 cells. Oh. Interesting. None of the files and folders can contain a 1, right? It's going to have to orthogonally connect to the rest, or none of the folders can contain a 1, because they have to orthogonally connect to the rest of the region, right, for that to work. But one of the files could be a 1. This can't be 6 because it doesn't have, every region needs to have a folder and a file in it. So it cannot be 6 here. Because 6 would mean that it has to see all 6 cells going that way. This cannot see 6 either. Because he can't see all of these cells here. Because then that would block this from being a full region. So we can't have 6 there. We can't have 6 here because it's blocked from vision this way. Actually, it could be 6. It could be 6 if it goes like that. Okay. 1, 2, 3, 4, 5, 6. So this cell must connect to one of these 2 cells here. This cell, so this cell, let's mark these. We'll make this pink and green. Or orange and green. We'll make this blue, this yellow, this pink, and this red. So red has to go to one of these 2 cells. Because otherwise it's not going to work. So this cannot see 6 cells. If it goes here, it cannot have a paper in the other cell, or in the file in the other cell. And it can't go 6 this way, because we're blocked by another paper. And this can go only 4 this way. So this can be 4 going at most here, or at most here. Green can only access these 2. Cannot reach any of the other ones. So this can be reached by green. Can it be blue? No. If it goes blue here, orange cannot access any file. So orange, this is green or orange. This is green or red. This could be green or pink. Pink could go here, here. Blue cannot go here again because that would mean orange doesn't have a file to go to. So blue could go here. 1, 2, 3, 4, 5, 6. Technically, it could go there. It could go here. I don't think it can get to here. 1, 2, 3, 4, 5, 6, 7. Yeah, I can't reach there. Yellow. Pink can get here, here. I don't think it could go here. So it could reach there. It could reach... Pink can get to any of these cells. Red can only go to one of those 2. Yellow. Can it go here? 1, 2, 3, 4, 5, 6. The problem with yellow going this way is it would have... These 2 cells cannot get to any other cells except yellow. And this cell can't get to yellow. Can't get to any other cell except pink. But the pink then would not have a file in the region. So yellow cannot go this way. Yellow can't go this way either. Because then it blocks pink from having a file. Or red. One of the 2. Right? Pink can't get to here if yellow goes this way. So yellow cannot be either of these. Yellow could be here or any of these here. This could be orange also. Orange can reach there. Technically, blue could go here. No, it can't. If blue tried to go here, the problem is... that green and orange wouldn't have access to a file. So blue cannot go that way. This cell, okay, where can this cell get to folder-wise? It cannot get to pink. 1, 2, 3, 4, 5, 6, 7. It cannot. It could get to blue or yellow. So this has to be blue or yellow here as a cell. Can this get to pink? It could, actually. So this is blue, yellow, or pink. This is also blue, yellow, or pink. We cannot have orange here. We can't actually have any... I think this has to be blue. Yeah, because if any other color goes here, blue has to go this way, but then it can't actually get to another file. So this has to be blue here. This is red, pink, or yellow. That's not helpful. This cannot reach blue. This is only pink or yellow here. This can reach red. So this is red, pink, or yellow. This could reach blue, technically. It could reach red. But if blue goes here, if blue goes this way, so say blue goes this way, can't get to here, because that's too many cells, to avoid these. But if it tries going this way, we have 6 cells which can only get to yellow. Because these cells have to go this way, but that's 7 cells in yellow, which is not allowed, so this can't be blue. What about red? You could do red there. Hmm. This can't be orange. We can't have any other color here, because if we try to get any other color here, orange could reach there, but the problem is orange wouldn't have a file attached to it. Blue can't reach there. Red would block green from being a 6-cell region, so would pink, and yellow can't reach there. So this has to be green. This could be orange or green here. We cannot have a different color, because then this green would be too small of a region. Can we actually have yellow there? No. If we try to have yellow here, the problem with that is green has to go here, orange has to go here, blue then has to go there, pink has to go all the way around here, though. And that's 1, 2, 3, 4, 5, 6, 7 cells in that region. So therefore, this can't be yellow. So this could be green, obviously. It could be red, it could be pink, it could be orange. Can this ever be... It could obviously be green or orange. Can it be pink? Red can't reach here. Blue would block off orange, and can it ever be pink? If it's pink, pink has to go this way. It can't reach around that way, but then green would be too small, so this can't be pink. So this is green or orange too. This is considered very easy. I don't see this. Anyways, pink could go here. Oh, can pink actually go here? If we connect pink to here, how does yellow connect to a um, red would have to go here, green would have to go here. But yellow, yeah, if pink goes this way, that's not going to work because yellow to access a file, it can't go here, right? Because again, these would not be part of any other region except yellow, and that would be too many cells in the yellow region. But if we try going that way, that's too many cells. 1, 2, 3, 4, 5, 6, 7. So this cannot be pink, which means this is yellow, which eliminates yellow as the files anywhere else. This is red, yellow, pink. These are red, yellow, pink. What happens if we go pink all the way over here? If we go pink all the way here, the problem is we have 17 more cells, which can only belong to 3 regions. Whereas we already have 2 of the cells in the regions accounted for. Sorry, it's 13 cells. Well, it would include these. So if we had pink going that way, right, so that would be 18 cells, not including 2 folders, but then to add, that would be for 3 regions, and the red is a separate region. So we can't have pink going that way, which means this must be blue. So blue cannot be here. This is orange or pink. So this is at least 3 cells. Um... Why couldn't this be 6? Because this would be too small of a region, and it doesn't have access to a file. Right. Um... I don't think pink cannot go this way anymore, because if pink goes this way, that blocks yellow from connecting to its file. So no more pink here, no more pink there. This can't be accessing, pink can't be here, so this is blue or yellow. This is yellow. One of, technically yes, we have to go, one of these 2 is yellow. So we have 1, 2, 3, 4, 5. Or 1, 2, 3, 4. So we can never access this yellow here. That, and also we can't have yellow go that way. That would block these from being a region. So these cannot be yellow. These have to be the same as this. Well, not necessarily. 1, 2, 3, 4, 5, 6 is possible. So what happens if orange is here? Or pink is here? If pink is here, orange has to get to here, which means green has to get to here. Which means red goes this way. What happens if pink goes that way? If pink goes this way, that means all of these have to be pink. Red would go this way. This would then be orange. That would be green. That seems feasible. Oh, this is not seen by this cell here, so this can't be 6. So blue technically could go all the way over to here. Technically, we could have all yellows go that way. Can this actually be red? Yes, it still could. Okay. Let's put all colors here. Blue cannot go here because that would block off orange. Red can't even... Red could reach there, but that would block off... Well... Red could go there. Yellow... Pink... Green cannot... green can reach 6, 6, or 6, so green cannot be there. Red technically could get there. Blue 1, 2, 3, 4, 5, 6 cannot get to here. Cannot get to here. It could get to here. 1, 2, 3, 4, 5, 6 that way. I don't think yellow can go this way. If yellow goes here, oh, they could exit out that way. Yellow cannot reach here. That would be too many cells in the region. We have 3 cells in the region, so we have 1, 2, 3 more. You could go 1, 2, 3. You could go technically 1, 2, 3. So yellow cannot reach here, cannot reach here. Can we get yellow here? If yellow goes here, the problem is these 2 cells would all have to be part of yellow, and that would be 7 yellow cells, guaranteed at least in this region. So this can't be yellow, which means this is blue. So this is at least 4 cells. We can only move 2 more cells for blue, so this can't be blue here. This can't be blue there. This sees at least... Well, we don't know if that... One of the files is corrupted again. Um, can this be yellow? 1, 2, 3. Yep, 4, 5, 6. That's possible. I don't think I would consider this very easy. This is not very easy. I would say possibly easy, but even, I don't know. This is a pretty fairly not kind of involved puzzle. We know there's a boundary here. Okay, what happens if we make this yellow? So if we go yellow here, what happens if we make either of these yellow? So if we have yellow there, so say we had yellow go there. I think that's too much. That means green has to go this way. We have only 10 cells available for 2 regions, which is not a lot. So yellow cannot get here. And I think we have something similar here. Though here we could have... Oh, that's kind of problematic. Oh, well, no, that's fine. The problem is this. Well, orange could go there. Never mind. So that could work. This. So if yellow is not here, that means this is blue has to get to here. I don't think green could get to here. We have 1, 2, 3, 4, 5, 6. Okay, so green definitely can't get there. Technically, it could go here. What happens in that case? Oh, that's problematic because these could only be orange then. So if we reach to here, or here, orange has to be here, but then orange has to also connect with here for the file. And orange would then be a 7-cell region, which is too big. So green cannot go here or here. Can this ever be orange? Wait. No, 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 no. This could be orange here. Because orange could go... Oh, no. This can't be green. Because if this is green here, it cuts off pink from accessing here. Okay, so if green goes this way, the problem is pink and red only have access to 9 cells, which can't form two full regions, which they'd have to. Why couldn't this be pink again? Because it can't access one of these files. Because red would have to go this way, but then pink would be blocking here. And then pink would also have to... Pink or orange, green... Pink or green would have to be here, and red would not be able to form a 6-cell region. That's the reason why. Blue can't reach here because of that. Pink cannot go that way because that blocks yellow from yellow. Yeah, so that's why this can't be pink. And it can't be red too far away, can't be blue too far away, or orange or green. That's too far away. Um... Oh, I see one thing. No. No, never mind. There's one interesting aspect here was if red went this way, these would see the same number of cells. So one of this file would then have to be corrupted. But red can also... The thing is, red could go here and then go there. That is possible. So then this would not necessarily... The red file would not necessarily be corrupted here, which is the issue that I'm trying to... because the problem is, since one of the files is corrupted, we can't limit the files yet, which is kind of problematic. You might just have to trial and error this one. Can we actually get orange here? I don't think so, right? Obviously need access to a file, so going this way... Well, going this way would block green. And they would have to enter in through here, which means it would have to be V6, but green would again to be too small. So orange cannot be there. I was hoping this would be an actual very easy chaos construction puzzle, but this is not a very easy chaos construction puzzle. So either this cell has to be the same as that, if that's blue, or these two cells, these would have to be the same as that, if this is blue and they had blue here, and this is blue and we have blue here, or if we had blue these, that means these two cells would have to be the same as those two. which doesn't tell us very much. Can we go orange here? I don't think so. 1, 2, 3, 4, 5, 6. Means all of these would have to be green, but then we don't have access to a 5. So then this would be 7 cells that are green. So no orange. And if we had tried to go orange with this way, that would mean 1, 2, 3, 4, 5, 6, 7 cells would have to be green, which is not possible. So this cannot be orange. Same with this. Well, we could technically have red and green go that way. That is a little problematic. If we have red go this way, this would leave green here. This would see 4 green cells. This would see 4 green cells. This would see 4 red cells. And this would see 4 red cells. So, no, red can't really go that way. What about pink? 1, 2, 3, 4. Technically, it could do that. So that could actually be pink. That's a little problematic. So the only ways you can get to pink would have to be like that, or pink that way. And if we go pink here, these would then all be green. This would see 3 green cells. This would see 3 green cells. And that, well, technically that still could work. This would see 2. This would see 4. Yeah, maybe. How are people thinking this is very easy? They might. I don't know. I don't see how people see this is very easy. Anyways. Um. No. Hmm. Can we have pink go here? I mean, we could. Hmm. Can we get pink here? Obviously, if pink goes here, that blocks orange. It would have to go through here because that blocks orange from that file. So it would have to do something like that, or that, or that. So orange would have to go here. Green would have to go here. Okay, so we have pink going here. That is 13 cells, which must be orange or green, which is too many. So that doesn't work. But this could work here. That would be 12 cells, which have to be orange or green. And it could always go that way. This is... I don't understand why people are saying this is very easy. This is not very easy at all. I don't understand what people are thinking that. There's too many options here. Hmm. Can this actually be pink here? If we have pink go here, we need access to a file. If we go pink here, we can't go pink here. We can't go pink here. That would force these to all just be pink, which is 7 pinks in a region. But we can't go this way. So red would have to go here, but then it's only 4 cells as a region. So I don't think this can be pink. Can this be pink here? I guess we could have like 6 pinks here. We can have red go that way, and that's perfectly fine. But we can't have pinks go that way because then these 2 cells would have to be pink because red could not go this way. Pink has to access one of these 2. Because if red goes this way, then it's stuck. If pink goes this way. But you could have pink go this way. And technically this. And these would have to be different. This would have to be the corrupted file. So that is possible. We could have pink go this way as long as red enters these. Um, this is just... There's too many possibilities. I don't get why people said this is very easy. This is not very easy. I was hoping this would be a nice introduction to chaos constructions, but this is not. This is very quite complex. Even for a 6-cell region, there's still way too many possibilities here for this to be very easy. um... Because the problem is, if we had the one file being corrupted, makes it so that we don't have anything reliable for the files. But we have to go through all the different variations on it to be able to do that. And that's non-trivial here. Even if it's only just 6 cells in a region, right? So it's that non-triviality which forces this to be not a very easy puzzle. I don't even know if it's easy necessarily. This is sort of taking almost on the build like a challenging level puzzle. Because you have to go through all the variations here, right? You have to go, oh, what happens if we go green here? What happens if we go orange here? And there's all these different paths that we have to test out. And that's non-trivial. And a very easy puzzle can be almost trivialized in a sense. Ah. Okay, what's the best way of... Okay, what happens if we have yellow here? That means we must access yellow this way. These would all be yellow then in that case. Blue could be, that would mean yellow could not longer be any of these. Which means this would be red, so this would have to be red going that way. Which means these would be red here. So red would no longer be possible anywhere else. So this would be pink. This would see 3. This would see 4, but that doesn't tell us much. This sees 4. This has to see... This is an error. Because this would see 4 and 4. So this would see 1, 2, 3, 4 cells here. So that would be a 4. We see pink, pink going one of these or one of these. So this has to be not 2. No 4 there. We don't know what that is. This would either be 4, could be 5. 4, 5, 6 is possible. Ugh. See, this is the problem. Like, going through every iteration is still kind of a pain in the butt. And execution on this is nowhere near very easy levels. It's definitely more along the challenging levels. So these would have to see different amounts. So either we have blue here twice or blue here twice. So this would be a 4-6 pair, I guess, in that case. Therefore, there's no 4 that way. Okay, what happens if these are both blue? This would have to be 5. This would have to be something different. So this couldn't be 5 here, which means this cannot be orange. It's green. So blue could no longer be here. Blue can no longer be here. So this would be a region. This has to be yellow. Because if it's not yellow, we can't access both this and this. And still have a 6-cell region. And it would block another region from being there. So this has to be yellow. This must be something different. So this has to either we have a yellow, extra yellow here and no extras here. Or we have an extra going this way. See, this is why I don't. This is not very easy as a puzzle. Um, because the thing is, you have to go through every iteration, which is fine. It's bifurcation, but that's every iteration, and there's a lot of iterations you have to go down. So these are not trivial to do. And that's actually why most chaos constructions, I figure, are challenging or harder. I thought that a 6-cell one would be potentially easier, but the problem is the ambiguities in this make it so that you don't actually have enough restrictions. Instead, you have to go down all the bifurcations, which I am fine with, but this is not a very easy way of doing things. So anyways, let's continue with this. Say we have orange go here. That eliminates orange in the rest of the grid. Green has to go this way. Green has to go here. This can't be green. That blocks pink off from this cell here, which means this must be green there. That's 1, 2, 3, 4, 5, 6. So that's done for that. Green has to go here. Red has to go down. So no pink here. It's all red. This can't be red. This can't be red. It cannot be green. You can't have all the pinks go here because that's too many. So this has to be blue. So that eliminates blue in the rest of the region. We have yellow go here. So this must be yellow that way, which eliminates yellow from being here. No yellow or pink. No yellow or red. Therefore, these would be the regions. And you'd have the same thing here. So then this would be 5. This would have to be 2, because these two cells see the same number of cells, and they can't. So this must be the corrupted file. This sees 3. This sees, aha, we have a contradiction because that sees 4. And then this is contradictory. So yeah, orange cannot go there. That's all we've proven. And again, like this is what you have to do. Otherwise, you're going to get, I don't know. No orange, that's green. what happens if this is orange here? So if we have orange here, we could go 2 down here. We could go a single down there and a single down somewhere else. Oh. Well, that's one thing. We know we can't have blue, blue here. Because if we have blue, blue here, orange can only go here, and it can't go down here. Because if orange goes down that way, that blocks green from being to a full 6-cell region. So this cannot be blue anymore. So one of these two would have to be orange if we go that way. Technically, we could go that way. And then we have to try all these variants here, right? We have to try with that one going there and then here, or that one going here and then here. We have to try variants like that. Okay. Anyways, let's try all the variants. So orange here, orange here. These are not orange anymore. Therefore, we have to have pink go this way. Therefore, this can't be pink. This must be green. We have to have green go here. That means green has to go that way. Red has to go down. Okay. Maybe that's... yeah. That's interesting. So anytime we go orange is here. So say this is always orange. So no green or pink. The problem is green has to go down here, right? That means this must be green here. That means red has to go this way, which means this is always going to be 4. And this has to be the same. Okay, so that's the contradiction. So if orange goes here, green has to go this way, red has to go this way. This has to be different than this, so this must be the corrupted cell, which means this cannot see 4 cells. But we know these have to be all the green cells, so that means the green has to go there, which means this sees 3 cells, and this sees 3 cells, which is a contradiction. Okay, so that's, I guess, where we find that. So, and I think that's, even if this is pink, you have the same problem. So if this is pink or orange, this is always going to be green, which means red has to go there. That's 4. This can't be 4, so that's the corrupted cell. This can't be corrupted then. And it has to see both of these. And it cannot be 4, because this is 4. It doesn't have to... well, yes, it has to be 4. You can't go this way as a region. It has to be 4 straight down if that's the case. So then I think this has to be green then. So this is not orange and not pink. That's green. That means green cannot be here. This is a red-pink pair. This can't be pink. It's orange. So orange could go around that way. It could just go straight down. So orange has to go that way, or it has to go that way. Right, we have if pink goes this way, red has to go this way. This can't be green anymore. That would be too many cells in the green region. Pink cannot go here. Red cannot go here because that would block orange from connecting. Green could technically do something like this. Okay, so pink can no longer get up to here. If pink tries to go that way, it has to go through here for this file. These would see that all of this would be green, so these would see the same number of cells. So one of them this would have to be corrupted, but then red would have to go down, and then that would have to have the same number of cells, and they would have a repeat. So this cannot be pink. Cannot be pink. Can we do green, green there? If red goes this way. So what happens if we go green, green, no blue there, no more greens. We can't go red going down that way. So these are all pink. No more greens here. These would see the same number of cells, which is 2. But this would be 2. These would have to be red. Red. Obviously, these can't be red. These can't be red. So we have yellow, yellow, yellow. That's 4 yellows, so it cannot be... It could be yellow, yellow there, technically. This sees 2. This sees at... This is going to have to see at least 4. At least 4. It could be 5. So this would be 4 or 5 here. This sees 3 or 4. This sees 4 or 5 also. Which would mean this would have to be 3 because of the 4 or 5 pair in the row. So then this would not be red. This cannot be red. It can't be pink. Because we have only 4 cells. We can go only 5, 6. No pink there. No pink there. No pink there. That's yellow. So that's 5 yellow. So this cannot be yellow, which means this is a blue. So this must be 5. But that's problematic because this is only 4. It has to go red, red here. Which means no red there. This sees 4. Well, 4, 5. 4 eliminates 4 here. This would see 5, which it doesn't see. It sees 1, 2, 3. It sees 1, 2, 3, 4, and then a 1, 2, 3 here, and then a 4th here as one of these two. So that's a contradiction. Ugh. See, this is you have to go through every single one of these. So this cannot be green, which means that's orange. So we have 3 orange here. We have a 4th one here. We only have 1 more orange, so this can't be orange there. We can't go over orange there because that would be too far. We have 4 greens here. We need to connect in one of them, so this can't be green. Same with this. This can't be green because we can't connect here and then also connect to here with that cell. So those are no longer green. What about if this is not green, if this is not orange? Well, let's try this being blue. If we have blue here, that means this can no longer be blue. Orange has to go all the way around this way. Also, we know since this is orange, this has to be at least 3. But yeah, let's continue. So yeah, let's make this blue, which means all of these would have to be orange. There's no orange there. It's green. No more oranges in that region. This is blue, so this can't be blue anymore. This can't be blue anymore. That's yellow. This is done as a region. This would see 3. That would see 2, but we don't know if that's invalid. This sees either 2 or it sees 4. We don't know which. We don't know about this. One of these is green. So if this is green, this has to be the encrypted file. Otherwise, we could go here, and then this would be 3. That is potentially possible. Hmm. This can't be 4 because it sees at least 5 cells. Obviously, if that's blue, this would be the corrupted file. So 3 would have to be one of those 2. See, this is why. It's like you're running through all the friggin' scenarios to do this. So at least 3. What happens if this is not green? That's orange, which means this has to be green that way. Which means this sees at least 4. This sees 4. It has to connect this way, so no blue here. These can't be orange anymore. One of these is green. We're not sure which. So this would be done that way. This has to see more than... It can't be 4 here. So this is 5 or 6. It has to be 5. That means this is 5. That's 4. This sees... Well, we don't know. So we have to go down to here to see 5. This cannot be blue. This can't... This only sees 4. It already sees 4 here, so no green there. It's pink or red. So it must go down there as the green to be a valid region. This has to be the same as, which it can't be red. So this has to be pink all the way over here. That means we need to get a file here. It can't be here because so this has to be pink, which means this can't be pink. This is red. These can't be pink either. These can't be pink. This can't be red either. So this is done as a region. This sees, oh, we have a duplication. 4 and 4. So this cannot be orange there, which means it's green. This is so we know this is 3. So this is green. We have one more green left. We don't know where it is. This is 3. It only sees 3 cells. That's 3 in the corner. We celebrate because I don't know. I'm not sure why we're celebrating. Because this is still potentially valid. We could go down this way. So what happens if we go down this way? So this does not see these 2 cells. So this is 2, 3, or 4 here. This is 3. That eliminates 3 in the rest of the row. So we have 1, 2, 4, 5, 6 left in the row. 3 has to be either here, here, or here. So what happens if we do orange all the way down? That eliminates orange from the rest of the row. One more blue here. That means this can't be yellow. It's all blue. This would have to be 5. Because it only sees 5 cells. Oops. So this would be done as a region. Yellow would have to go here. This is done as a region. These 3 digits must match these. So we have 1, 2, 4, 5, 6. No 5 here. 3 has to be here. These 2 see the same number of cells. So this must be counting exactly correct. This sees at least 3. This sees... Oh, we have a contradiction. No. So this can't see 3 here. It can't see this one here, so this is 4, 5. And this must see 1 more than this, because these see the same amount in this row. So this must be 4, which makes this 5. So we must see up to yellow here. And one of these is yellow, which eliminates yellow in the rest of the box. No 4s here. And then we have a contradiction, because this must be 4 to spot the number of cells. So, what does that tell us? It just means this can't be orange. That's all. Now, that's interesting. This is not very easy. I don't know what people are thinking when they're basically labeling this very easy. This isn't even very easy for a chaos construction. You have to go through a whole bunch of bifurcations to do this, which means that the execution is definitely not very easy, and it's just not easy for a KS construction rule set either. I don't know what people are thinking. Anyways, it's a good puzzle, but I people vastly underestimate how difficult this is. Okay, anyways, so we could still go here. We could go here and then here, or here then here. But doing this, hmm. Oh, can this ever be green? If this is green, that would mean these two cells see the same number of cells, and this file would be corrupted. So then these must see different cells. So this cannot, well, so if that's green, obviously neither of these are green. This is the corrupted file. This sees 4. So no 4 there. 4 is guaranteed to be one of those two. This is the corrupted file. There's no 4 here, so this cannot be going this way, which means red has to be going that way. So then red must be going that way. This must see only 3, so this can't be red. This can't be red, obviously, anymore. Red has to go something like this, though. So red has to go here, then here. This can't be yellow or pink. So we'd have to have orange here. This can't be pink, it's orange, orange. No orange there, it's blue. This can't be blue. So it'd have to be... It can't be pink. So this has to be pink here. None of these can be red anymore. So we have pink, pink here. This must be pink, pink here. And we have a contradiction because these see the same number of cells. So, we've shown this can never be green. So green has to go around this way. This must be a 2. That eliminates 2 in the rest of the region. So we have to have a 2 here. This must see 3 cells. Guaranteed. But it doesn't actually have to be a 3. It could technically still be the invalid, the corrupted file. It's very unlikely to be, but it could be. No 2 here. If we go this way, that means this can't be red, because that would be a 3-cell region for the red. So this is pink. No pink here. No pink here for the red. This is 4. Could be 4 there. This has to be pink that way, because we don't have access to both of these. Because red has to expand somewhere. So this has to be red here guaranteed, and one of these two is red. So this must be pink that way, if that's the case. This cannot be green. No pink or red. So this is guaranteed to be orange. This sees at least 5. This is 1, 3, 4, 5, 6. One of these is a 3. That eliminates 3 in the rest of the column. This must see a different number than the cells that it sees. So this must be a 3 then, in that case. Okay. This must see 5 or 6. This sees 1, 2, 3, or 4. Cannot be 4. So this can't be pink. So this sees 3. This is still 5 or 6. Red is still here. That means red is done, so this can't be red here. Obviously, these can't be red. Yellow has to go here. Which means we cannot go 2 yellows here. We could, actually. This can't be yellow, it's orange. So orange has to go that way, which means that can't be orange there. This is 5 or 6. We cannot have blue here, then both of these would be C5 cells. So no blue there. This is yellow, pink as a pair. This can't be blue anymore, it's yellow, which makes this blue. So this sees 6, this would see 5. 5 eliminates 5 here, so it's 6, which means this can't be pink, or sorry, can't be yellow. And we have a contradiction here, because then these would see the same number of cells, and they would both be 4. That's a long, convoluted way to get there. Anyways. Okay, so we know this can't be green now. So therefore this must be green here, which means you have to go orange, orange here. So then that's done. Green is done. We have 1, 3, 4, 5, 6 here. These cannot be 2. No 3. It's 1, 4, 5, 6 here. This can't be 3. We have 1, 4, 5, 6 there. 3 is one of these 2. This sees 4 or 5, cannot be 6. If red goes this way, it has to be 1, 2, 3, 4, 5, 6. So this can't be red here. Can this be pink either? 1, 2, 3. If this is pink, that means it cannot go here because these would then have to be pink. It can't go here because then all of these would have to be pink. So pink cannot be here. This is blue or yellow. Okay. This, well, we don't know what this is. So 3 has to be one of these 3 here, but that doesn't tell us much. I need to pause. I'll be right back. I need to go to the bathroom. And I'm back. Let's continue with this. This is likely 3. This is likely 4. But we don't know. Right? These 3 digits match those 3. This must match one of these. It can't match this one. Can't match any of these. It matches either here or here. We don't know which, again. Remaining digits of column 6 are 1, 2, 4, 5, 6. Okay. So these are the same colors. That's all we know. We'll mark those as dark. These are the same colors. So these will mark those as medium. So these have to be different sets. Well, this one doesn't have to be. Yeah, this one. No, it does. It has to exit out. Um, we could. No, we can't. So this has to be the same region as this, because if it's not the same region, if it's red, it has to go down there. If it's pink, red has to exit out this way, which means pink has to go out that way. So this is guaranteed to be part of that region. Remaining digits, this could be all of the digits here. So we have all the darks here. We could have... Okay, so if this is red and this is pink, this is guaranteed to be the corrupted file. However, if red goes this way, pink could go something like, oh, this actually could be pink over here. So this is not yellow here. This could actually be pink here. I'm kind of messed that up. Because we could do that and yellow could go there. Ugh. And this is why it's frustrating. Anyways. Um if this is red, it has to go red all the way here. That means this would be corrupted. Um so if red goes here, this has to be that same red. Because you can go both here or both here. You can't do both of them here. This can't be red here because it's too far. If this is not red, this is pink. So all of these are pink. And red has to go that way, which means we need two pinks. So this is guaranteed then to be medium. So then with either of those being medium, that's potentially possible. Um, can the dark ever go here? So if dark goes here, that means pink would both be here. Okay, so when can dark not go this way is the question. And the answer is dark cannot go this way when it has to be part of pink. So then all of these would be part of pink. These would all be red. But the problem is this would see 5 cells, this would see 5 cells, and this would have to then be corrupted. But this would see 4 cells, and that would see 4 cells, and they would have to be corrupted. So, no, this has to be dark. So this is dark all the way. This cannot be pink anymore. It's yellow. So this sees at least 3 cells that way. So this cannot be 3 here, which means one of these two is a 3. So this can't be 3 here. It's 1, 2, 4, 5, 6. We cannot go blue there, so this must be all 5 blues that way. Because it can't go more than there. So that's 5 cells only. It can go either there or this way. So this is guaranteed to be 5. This is not yellow, it's blue. That eliminates 5 in the rest of the column. It's 1, 2, 4, and 6. 5 eliminates 5 in the rest of this row. So this is all done as a region. So we have boundary here. So if this is the region, it sees 5 cells. If this is part of the region, it sees either 2 cells or 4 cells. So this is not 3 or 6. This, again, only sees 3 or 4, which is valid. It can see 4 going that way, it could see 3 going that way. Uh, hmm. One of these is yellow. So this cannot see it, and it doesn't see that one. So this cannot be 5, it's 3 or 4. The other yellow has to be one of these two. So it will guaranteed see both one of those two. So it doesn't see this yellow, it doesn't see one of those yellows, it will guarantee see that. So this is a 4. That eliminates 4 in the rest of the row. This cannot contain, so we have a 3 here, and we can't have 4 here. So this is 1, 2, 5, 6, which means 4 in column 5 has to be one of these 3 cells. So that means this can't be 4 and that can't be 4. This is 1, 2, 3, 5, 6. So we could have a 4. No, 4 eliminates 4 here. It eliminates 4 here and 4 here. So this could still be 3. This could still be 4. And that would not be corrupted. What happens if we have blue go here? Then this is not blue, it's yellow. This would be corrupted. So then red cannot go down. Red would have to go this way. This would be pink, obviously. This could not be 4 and cannot be corrupted because this is the corrupted file here. So these can't see the same number because this can't be corrupted. So then this can't be pink. This is yellow. Right, we have that. So we know this is a medium yellow pair. Again, if this is not yellow, it's blue. That means this can't be blue, it's yellow. This sees 4 cells. This is the corrupted cell. So this can't be corrupted. It sees 1, 2, 3, 4. It has to see 5. So that's 5, which means this is not medium. This actually looks fine. This sees 2, this sees 4, this sees 3, this sees 4. That seems okay. This is 3. Okay, let's try the other way then. Okay, gray is red. Let's try, so dark is pink. This sees 5. This sees 4, and this is corrupted. So this sees 1, 2, 3, 4, and we have a contradiction. Okay, so that's the contradiction there. So this pink cannot be here. Therefore, the gray has to be the pink cells. The dark has to be the red. So these are red, and the gray cells have to be pink. Medium gray, I guess. So this is boundary here. This sees 3 cells. This sees 4, but we don't have to actually do anything there. This can't be 3. So 1, 2, 4, 5, 6. No 4 here because of 4 in the column. If pink is here, these would both see the same cells, and this would have to be corrupted. So this couldn't be corrupted, but it would also see 4 cells. So pink cannot be here in that case, which means this is yellow. There's no yellow here. This is pink, pink, pink. So this sees 2 cells. So this is done as a region there. No more 2s in the rest of row 4. This has to be 1, 4, 5, 6. The remaining 3 in row 4 has to be here. So this is 3, which has to be the blue 3, because blue needs access to a 3, so this can't be blue here. So blue is done as a region. 2 eliminates 2 in the rest of the box. Where is the 2 in the red region? Can't be here, can't be here, can't be here. So it must be there. That eliminates 2 here. One of the files is corrupted. Three cannot be here. So this is 1, 4, 5, and 6. So 3 has to be one of these digits here. That eliminates 3 from the rest of the box. So then 3 has to be either here or here. This has to be 1, 3, 4, 5, and 6. One of them is corrupted. 1, 3, 4, 5, 6 here. So obviously this sees 5 cells. This sees 4. This sees 6. This sees 4. This sees 4, but we don't know which one's corrupted. Right. Okay, so let's mark the ones with... Okay, so if it's not corrupted, that's 3. If this is not corrupted, it's 4. If this is not... Oh, okay, so one of these has to be corrupted. There we go. So one of these files is not a 4. This sees 4 cells, this sees 4 cells. So then this can't be corrupted. It sees 3. No 3 here. One of these 2 is a 4, so that can't be 4 here. This sees 6 cells. So this is 6. This sees 4. Can't be corrupted. This sees 5. Can't be corrupted. No 4 here. No 5. Rest is the yellow region. This can't be 5. No 6 here. This can't be 6. It's 1. No 1 or 6 there. It's 2. This has to be 4. That eliminates 4 in the rest of the pink. Well, we already knew that. No 4 there. 5 eliminates 5 in the rest of the column. No 1s here. Remaining. 2 cannot be here. 3 eliminates 3 here. Where's 3 in the pink region? It must be here. That eliminates 3 here. Where's 3 in the yellow region? It must be here. 5 means this can't be 5. One of these 2 is a 5. That eliminates 5 here. 6 eliminates 6 in the rest of the row. No 4 here, so this is 1, which makes that 5. This can't be 5 here. or 1 here. It's 4, 6 as a pair. That eliminates 4 and 6 in the rest of the column. No 6 here. It's 1, which makes that 6. That eliminates 6 in the rest of the box and column. 1 in the rest of the region. So this is 2, 6 as a pair. 4, 6, and 1. Eliminate 1, 4, and 6 there. It's 5, which makes this not 5. So it's 1 and 5, which makes that 1. No 1 or 5 there. It's 6. No 1, 5, 3, or 6 there. It's 4. 4 eliminates 4 here, so it's 6 and 4. So this can't be 4 anymore. That's 6, which makes that 5. 6 eliminates 6 here, so it's 2 and 6. That leaves that as a 2, this as a 1, and this as a 4. That was not very easy. What are you guys smoking? Sorry about this. Usually people are good at, even if it's not very easy, these puzzles can be easy level for the hardest part, but this is not easy level. This is challenging at least. I don't know what people are talking about saying this is a very easy puzzle. This is not very easy. I'm going to probably rate this hard because everybody else underrated it so hard, so much. This was not a very easy puzzle. This was not even close to easy. I even question whether it's actually challenging. Anyways. Well, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.